Okay, today we're going to talk about fractions. We're going to talk about both adding and subtracting as well as multiplying and dividing. Let's first talk about adding and subtracting. When you have two fractions, say 1/2 and 1/4, and you want to add them, the very first thing is you have to have what's called a common denominator. So that would be the bottom of your fraction is called a denominator, top is the numerator, and this number on the bottom has to be the same. You cannot add fractions if they're not the same. The most common mistake is to just add the numerators and say this is 2, add the denominators to say it's 6, and this is not correct. You cannot do that. You got to get a common denominator. The way we do this is we look for multiples. So the first question is there any way that I can multiply 2 and get 4? Well, fortunately the answer to this is yes, because 2 times 2 is 4. So we're going to multiply this bottom by 2. And whatever we do to a bottom of a fraction, we must also do to the top of the fraction, otherwise we've changed the fraction. But you can multiply the top and the bottom to change the way it looks, but it still keeps the fraction the same. So we're going to multiply the bottom by 2, so we get 2 times 2 is 4. Multiply the top by 2, so 1 times 2 is 2. And if you look, the fraction 2 out of 4 is the same as the fraction 1 out of 2. 1/2 is out of a pizza would be the same as 2 out of 4 slices of pizza. So these are really the same fractions, they just look differently. However, now our denominators are the same, so we can add the fraction up. When you add a fraction, you add the numerators, so we get 2 plus 1 is 3, and the denominator just stays the same, which is why it's so important that you get a denominator that's in common first before you add it. So this is 3 out of 4. And then the last thing is we're going to reduce these fractions if it is possible. And you can tell if something's reducible if there is a multiple that's in both the top and the bottom. So for example, if we had the fraction 6/8, I can divide both the top and the bottom by 2. So when I divide the top and the bottom by 2, 6 divided by 2 is 3, and 8 divided by 2 is 4. So now we can reduce 6/8 to 3/4. So make sure you're reducing your fractions. It's not correct if you don't reduce your fractions. Okay. Well, what do we do when denominators are the same? Well, then it's even easier. You just simply are ready to go and you add them up. What if you can't just multiply this 2 and get this 4? So let's say we have something like 1/2 and 1/3. And I want to add these up. There's no way I can get 2 and multiply by a number to get 3 that's an integer. So what we're going to end up doing is we're going to multiply both of these, and we're looking for what's called the least common multiple. So what you want to do is figure out all the multiples of 2. In this case we got 2, 4, 6, 8, 10, 12. And do the same thing with 3. 3, 6, 9, 12. And then you want to find the smallest number that's in common. So over here we had 2, 4, 6, 8, 12. And on the right side we said 3, 6, 9, 12. And we could keep going forever. But we have two things that are in common. We have 12 that's in common, and we have 6 that's in common. Well, least means the smallest, so we're going to use 6. So I need these bottoms to be 6. So our new fraction is going to look like this. We have bottoms of 6. And now we got to figure out what our numerators are. So you go back to the original and you go, okay, I started with 2. I need 6. I got to multiply. How did I multiply 2 to get 6? Well, we multiplied it by 3. Let me change the color here. So we're going to multiply this by 3. And whatever you do to the bottom, you also do to the top. So we're going to multiply this by 3. And 1 times 3 is the number 3. We're going to do the same thing over here. How did we get from 3 to 6? In this case, we multiplied by 2. And once you do something to the bottom, you always do the same thing to the top. So 3 times 2 is 6. So 1 times 2 is 2. Now, if we look back over here, we have common denominators. So we can go ahead and add. You add the numerator. So 3 plus 2 is 5. And the bottom stays 6. So 1/2 plus 1/3 is equal to 5/6. And again, we're going to check to see if it's reducible. And there is nothing in common that we can reduce it. So 5/6 is the answer. If you're ever unsure on if something's reducible, you can always put it in your calculator as well. And RTI Inspires will automatically reduce it and leave it as a fraction for you. Alright, let's look at subtraction. So I'm going to clear everything off here. And let's look at subtraction. So subtraction is exactly the same thing as addition was. So let's say that I have 1/2 minus 1/4. Well, first thing we got to do is find a common denominator. So I have 2 and a 4. I need that common denominator. And our common denominator, actually, you know what? I'm going to switch this up and show you something with negatives even. Let's do it the opposite way around. Let's go with 1/4 minus 1/2. Okay, so like I was saying, we got to find that common denominator. I can make 2 and a 4 by multiplying by 2, so we're going to multiply both top and bottom here by 2. So I now have 1/4 minus 2/4. Okay, and when you do that, denominator stay the same, which is 4. And now we go 1 minus 2 is negative 1. So this 1/4 minus 2/4 is equal to negative 1/4. So you got to remember your rules up here for when we did the addition and subtraction with integers, particularly paying attention to the negative numbers. You can do 1 minus 2, but you're going to get a negative number. So don't forget all the rules that we studied when we did negative integers. Okay, it's really important that you have that minus sign, otherwise the answer is completely wrong. You cannot reverse it and get positive 1/4. So you could have negatives on the 1/4 up here. You could have plus and negative. All those things, we could have 2 negatives, make this minus negative. All those rules that we covered with integers are still applicable here. So the only difference is with the fractions, you got to get that common denominator first. That is true for addition and subtraction. Okay, so anytime you have addition or subtraction of fractions, you must have a common denominator. Okay, if you have questions, make sure you ask, but I'm going to go on and talk about multiply. So let's get rid of all this, and now let's look at multiply. When we multiply, we do things a little bit differently. So let's go back to 1/2 and 1/4 just for ease. And we're going to put a multiply symbol in there. When we multiply, life is simple because you do not have to find that common denominator. So all that common denominator stuff that we just did, finding all the least common multiples, all that is just for addition and subtraction. When you're finding a common, when you're multiplying fractions, you simply multiply numerators, and then you multiply denominators. Okay, multiply numerators, multiply denominators. Okay, so we're going to multiply our numerators. So we have 1 times 1 is 1. Then we do the same thing with the denominators. 2 times 4 is 8. And we're done. The only thing we have to check is, can we reduce 1 over 8? In this case, the answer is no, so we're going to leave that as an answer. I'm going to go ahead and do one that we can reduce, just so that you can see what that would look like. So let's make this 1/2 times 3/6. I'm going to go 1/2 times 3/6. So you go 1 times 3 is 3. 2 times 6 is 12. And now what we have in common is a 3. Both of these are divisible by 3. So when you do 3 divided by 3, you get 1. And when you get 12 divided by 3, you get 4. So here is a case where you would have to reduce. Now there is another way to reduce. I think there's supposed to be a C in there. You can go back to this original one and you can look to see if there are pairs of numbers you can cross out. Now don't get carried away. This is not true for addition and subtraction. This is a multiply thing only. When you're multiplying, it doesn't matter if you go straight across or back and forth. Anytime you see things in common, you can reduce them. Here, 3 over 6 could have been reduced right here to 1 over 2. And now when I multiply, I get 1 times 1 is 1, and 2 times 2 is 4. The same thing is true if I had switched it up. Let's say I had 1/6 times 3/2. Okay, if we did it traditionally, you're going to still get 1 times 3 is 3. 6 times 2 is 12. And now we're still going to reduce it to 1/4. But here, I can't redo 1 over 6, and I cannot reduce 3 over 2. But here is your 3 over 6. So I can get rid of this 3 in the top and the extra 3 in the bottom, because 3 times 1 is 3, and this is 3 times 2, so it's the common 3 right here that we can reduce, and it leaves us 2 in the bottom. And now we're back to what we just did a minute ago, which is 1 times 1 is 1, and 2 times 2 is 4. So it doesn't really matter which way you reduce. If you see this, and that's easier for you, by all means use it. If you don't see it, and you just want to go ahead and get this and reduce at the end, there is nothing wrong with that either. So you decide which is easiest, and sometimes it's a matter of what do you see and what don't you see. But make sure, whichever way you do it, at the end, only 1/4 is the acceptable answer. You got to have it reduced. So negatives still apply if we had made these negatives. So if I had one negative, my answer becomes negative. And if we have two negatives, the answer becomes positive again, just like it did for integers. Otherwise, it's just multiply across. So tops get multiplied together in the numerators, as well do the denominators. Okay, lastly, let's talk about division. So I'm going to go ahead and erase all this, and we're going to do it one more time, this time with division. Okay, so let's go take 1/2 and 1/4 again. And this time we're going to divide. Okay, a nice acronym that we like to use for division is called keep, change, or sometimes keep dot, whichever, and then flip. Okay, keep means the first fraction stays the same, so it is still 1/2. The change means that we're going to take this multiply into a division into a multiply. So keep, change, flip, or keep, dot, flip. The dot representing the multiply. So that division is going to become a multiplication. The last step is flip. Flip means that we are going to take the reciprocal. It means that we take this fraction and we turn it upside down. So 1/4 is going to become 4/1. So keep, change, flip. Keep the first one, change the sign, goes from division to multiplication, and flip your fraction by taking the reciprocal. So you take that 1/4, flip it upside down, you get 4/1. Now it's simply a multiply problem. So we multiply across. 1 times 4 is 4. 2 times 1 is 2. And 4/2 has a 2 in common. You can divide top and bottom by 2. So 4 divided by 2 is 2. And 2 divided by 2 is 1. So our best answer is 2/1. And anytime you see this 1 in the bottom all by itself, you don't actually need this 1 down here. This is simply the number 2. And this is our best answer, is 2. Just like before, we could have looked back here. 1s have nothing in common besides 1, but 4 and 2 do. They have a common 2. So 2 times 1 is 2, and 2 times 2 is 4. So we can reduce it, and now we got that 1/2, and that gives you the 2 as well. So either way you want to do it is fine. But our answer to 1/2 divided by 1/4 is the number 2. That is the correct answer. And just like with multiplication, the negatives don't change anything other than the sign. So if you have one negative somewhere, the answer is negative. And if you have two negatives, the answer becomes positive again. Let me give you one more example to make sure that we're all on the same page. Let's give you something a little bit more complicated. Let's say that we have two improper fractions, so like 4/3 times, let's go with 8/3. Okay, nothing special that the thirds are in the bottom. We're not adding. We're going to multiply. Actually, let's make this into division. We'll make it even harder. So we're going to use keep, change, flip. So we're going to keep our first term, change the division to a multiply, and then flip our second term. Now, we could multiply across and get 4 times 3 is 12, and 3 times 8 is 24, and then reduce it. But look what's happening here. You get a 3 on the top and the bottom. When you recognize the same number on the top and the bottom, it's easy to just cross them out right now and make those ones. So you don't have to multiply it. Now I have just 4/8. Well, 4/8 also has something in common. It has a 4 in common. So 4 would become a 1, and the 8 becomes a 2, because 4 times 1 is 4, and 4 times 2 is 8. So we're going to divide both by 4. Now your fraction is simply 1/2, because you got 1 times 1 is 1, and 1 times 2 is 2. So this is one of those cases where seeing the crossing out, the things that are in common that you can cross out, actually makes this problem much more easy. If you hadn't, you would have gotten 12/24, which of course is also 1/2, because both 12 and 24 are multiples of 12. So our answer to the original question, 4/3 divided by 8/3, is 1/2. Okay, if you have questions, please make sure you ask, and I hope that this has served as a good review for fractions.